Hello, this is KOJRO with another short video for you, and this time it's also kind of off topic. I'm still working with 1581 drive, and I was going through the boom in my last video and I thought I had everything. But I have missorted my TTL chips, so in the box where I should have the 7407s, there was 7408s. So strangely, I'm not sure what happened there, but I don't have any 7407. So the 7407, as we will see when we go through the leaflets and the datasheets, it's just a buffer. And it's made to be able to draw more power from circuits, but in this special case, it's an open collector buffer, so you can't just omit it and collect the leads straight. So I did what any sensible TTL guy would do. I made my own. And this is just a short video to show you how this is done. And this is actually the whole point with glue logic in the TTL series, that you can use these chips to make some of the other chips in the series and also make other functions. So that's what I will be doing in this video. I will show you how I use a 7404 and a 7406 to make a 7407. So let's just jump straight into the datasheet. Before we start for real, we take a quick look into the datasheets of the 74 logic chips we are going to use. And as a good starting point, you can use the English Wikipedia page for the 74 series logic devices, where there are good links to almost every datasheet that you need. And what I'm missing is this one. It's a 74 LS07. Although my is not an LS, it's an ordinary without LS, and this means that it's lower speed and higher current draw. But as we will see, I can increase this a bit. This is just a buffer, it's nothing else, and it also used to drive CMOS outputs, relays and other stuff because it's open collector, and you can also drive higher voltages up to 30 volt with this one. And you see here you have input output, input output, input output, input output, input output, input output around the chip, and you have the GND and you have the VCC here. So this is actually what we need to emulate with our design. What we will do is actually to make a double inverter, because if you invert something 2 times, it's just a buffer. So what we will do is we take a 7404, that's an hex inverter gate with normal outputs. And it has the same configuration, input, output, and so on. But this is not an open collector. But this will be able to drive whatever circuit you have after it. So what I will use here is a 74 LS04 to save some current. And it's just going to drive one gate, so it doesn't matter much. And it's also a bit higher speed, so we don't get added delay in our circuit. And to use as an output, I'm going to use the 7406 that's also used otherwise in this circuit and in C64, and I also had this in another video where I went through this with open collector. This one is configured exactly the same, input, output, and it's 6 gates. But this time also inverting. So what we are going to do is we are going to run them through both circuits, and we are going to emulate the pinout of a 7407 chip. Let me make this a bit clearer with a drawing, or unclear in another way. First, I make a quick sketch of what the end result needs to be, and that is a 7407 chip. I have taken a peek inside the 1581 service manual, and I'm absolutely certain that I need open collector outputs on the 7407 equivalent we are making. because they have wired together two outputs, probably to make a logical OR function. Yeah, in order to clarify this in my own mind, I do have to make a sketch of what I'm actually doing. And what I'm doing is I'm taking 174LS04 and cascading it with 17406 to have the open collector output instead of the totem pole output of the 04. Yes, first I find the chips I need. It's a 74LS04 and a 7406. And I need to do some piggybacking or some other stuff to make this work, but it has to be a bit more complicated than that. I can cascade input and outputs probably this way, but I have no way to isolate the outputs and how to fit this into a PCB. I can use a socket and a lot of fiddling about, but I do think I'm going to use some kind of KOJRO board on this to make it stable and to make it possible to do some fault finding if I do something wrong or I need to find out something in the circuit that's not right. Yeah, I found a KOJRO board that I can use. I just have to measure out how much space I got and what way to turn this, and if we can make this work without putting in another socket or something, because we won't want to short out anything against the other chips. And each chip needs 4 of these holes to fit together, so it either has to be done like a long circuit like this, or we can make it work with turning this the other way and just cut it so that it will be just long enough for the 2 chips and the socket. And that way I do think we will get this to fit, and also we will be able to make all the leads and other stuff fit quite good. But first I need to find some round pin headers that will fit in the sockets so that it will be easy to plug this chip in when we are finished. When we turn the board around and place the ICs the other way around, you can really shrink this design quite a lot. So that will be the way we are doing it. We will be cutting this board to make place just for the 2 ICs and for the pin header that goes to the socket. Yeah, then it's just to take this piece down to the shed and cut it so we get it the right size. Yeah, now I'm finished cutting the board, so now I'm just doing some tests and some thinking to find out how this is most efficient placed so that I have to solder the least amount of wires and the easiest soldering. After a surprisingly short amount of time, I come up with this design that I went for. I shift each of the chips 1 position to the left. Then I don't have to wire up the 6 traces that's marked with the orange, the short ones. I just bend the legs and solder them to the pad that's next to it. I also have to wire up VCC and GND, and I also have to put a 100 nanofarad capacitor on top of this board for decoupling as the supply lines are getting kind of long. I start with soldering in the pin headers, and then I solder in the IC. And I don't use sockets for the ICs. That would limit my options when soldering leads direct to this. So I will not use sockets, but I don't think I will destroy these chips anyway. And this is just meant as a temporary solution while I get the 7407s for real. First I thought to use wire wrap lead for everything, but I changed my mind and went for a thicker kind of wire for the VCC and the GND. And that is because the long leads and a bigger power draw could actually cause some havoc. Yeah, thicker wires and small space is not always a good combination, so it's a bit fingering and trickery to get this in place, but I do manage to get this as an okay solution. And when I'm finished with all the thin wires, I'm also going to place a capacitor between ground and VCC as a decoupling cap to decouple the power supply on this board. And here I bend the legs of the chip so that they butt against the bottom of the pin headers for the connections that I don't need to hook up with a wire. And then I solder them in place afterwards just to the bottom of the pin header. And as I am quite stubborn, I refuse to change the tip of my soldering iron, so this rather thick one will do even for reaching into these small spaces. Then I start up with the thin wire from the wire wrap, and this is a rather good way of making connection because this wire is rather stiff, the insulation come off quite easily, and it's easy to solder. And I'm going to keep these as short as I need them to be, but not so that I will have trouble with connecting them in both ends. They also have to be routed around the chips, the socket, and the edge of the board. Several times during this operation I wish I had made a better schematics that actually showed which wire should be wired where, but that I didn't make until afterwards, and that was just to show you how this is wired together. Yeah, I made this simple schematic to explain what actually is going on here, and this is just a pin header that should simulate the 7407 result. And as you can see, I've just cascaded the gates here, 1 to 2 and 1 to 2 and 1 to 2 on this pin header. But when I wanted to reroute so that I could reuse the 6 tracks and don't have to connect them by wires, I actually ended up with a slightly different configuration, as you can see here. So pin 1 from the pin header then goes to pin 13 on the 74LS04, and pin 11 to 3 and pin 9 to pin 5, as we will see here. And the same with the outputs that is rerouted on top here. So this is actually the complete schematics for what we are doing here today. And you can see the connections between these are held the same as this one. We could have stocked more on the order of these to maybe save some millimeter of wires, but that was not necessary. And we have also connected the capacitor on top of these ICs as a decoupling cap to have some extra power reservoir on top of this board. And I'm by no means an expert in KiCad, so this might look a bit messy, but it's many years since last time I produced anything in a professional manner in CAD software for electronics. Yeah, to complete the board it was just more of the same. Thin wires that you have to route the right way, and it's really a joy to work with this wire wrap cable. And I thought all my wire wrap cable was destroyed because it seemed like the insulation was going bust, but this one is actually quite as it was when it was new. Yeah, I do think I've completed all the wires, so it's time to do some testing. And the first owner I'm going to give to the Minipro programmer to see if this recognizes this as a 7407 chip. And it does not. And if I look at this truth table, it seems like it's pin 6 that there are something wrong with. It goes to the high, that's open, and then it fails on the low. So that probably means that there is a bad contact on pin 6, and pin 6 here relates to the socket we have put in and not to any particular of the ICs here. I didn't have this at the time, but now we actually have made the schematic, so now we can actually go in and look what this should be. And here we can see that 6 on the DIL socket should be connected to pin 8 on the 7406. So that's where our loose connections are for sure. So with that fixed, we are going to give it another go in the Minipro programmer to test if it works okay now. Yes, so now it went through with flying colors, and that means that our Minipro programmer actually was for help this time. And we are also going to test this in the Retro Chip Tester Pro to see if the results are similar. This chip is not a looker for sure, but hopefully it works better than it looks. On the Retro Chip Tester Pro, we first have to choose that it's logic chips and that it's 74 series of logic. And then we just browse through to find the 7407 and hit test on that one. And as you see, it tests just fine. So we have a working 7407 chip ready to test in our 1581 drive board. Yeah, one step closer to finishing up this 1581 project. So that's it for this rather off-topic video, but I think my off-topic videos is the ones where I learn the most, and it's most fun to make actually. So hope you enjoyed the content. Please hit like and subscribe if you want to be notified when we post new videos. And as we said before, we are up in the hundreds very soon when it comes to videos. And we will be giving away a C64 in fully working condition. Just leave a comment below if you want to add something, you want to change something or something else. Otherwise, hit the bell for notifications. I hope to see you again in my next video. Thanks for watching.